I know you guys are super pumped up for solving rational equations and inequalities. So far in the unit, we have predominantly dealt with expressions, which expressions are things that do not have an equal sign. But now we are strictly dealing with items that have equations, so equal signs, and inequalities, so greater than and less than. And actually, you guys, these are not as bad as when we have an expression. So I think you'll enjoy this. Okay, so a rational equation. Oh, sorry, guys. All right, so we're going to start with some rational equations, okay, which when we solve our rational equations, if you see, we're going to have three lovely example problems that have an equal sign in them, which means these are rational equations. So here are our steps for rational equations, which I will go over this again when you guys do the awesome example problems, but I'll run through them real quickly. So what you will be doing in just a moment with examples 1, 2, and 3, we will be factoring only the denominator, just like when we had addition and subtraction problems. And the reason being, you guys, when we solve rational equations, our goal is to actually get rid of the fractions. We're going to make our fractions go away. We're going to be like little mathematicians and make all of our denominators disappear. So if all of our denominators are going to disappear, we don't really need to factor the numerators because we won't be looking to cross anything out because we won't have a denominator. We won't have anything to cross out. Okay, so we are only going to factor the denominator. After that, we're going to find the LCM, which is the least common multiple. So we want to find the smallest thing that our denominators will both equal when you multiply them together. Okay, which this is the same thing as when you're finding a common denominator. But I didn't want to call it a common denominator because our goal is to eliminate the denominators. We're not trying to get common denominators, we're trying to completely get rid of our denominators. So the LCM will help us to do that. So all of the LCM is the same thing as the common denominator. We're not trying to get common denominators, so that's why I call it LCM. But anyways, like we do with our common denominators, we're going to find where the LCM is undefined, which this is going to be really important in this unit, you guys, because we are solving for x. We're actually going to get a value for x, unlike when we solved with our expressions in the previous sections. Okay, so we have to make sure that our denominator never equals 0 or our kitten will die. And we don't want any kittens to die. Not allowed. Okay, so we're going to set each factor in the LCM not equal to 0 to make sure that none of our answers give us a value that will make the denominator go 0. Which remember, if you ever get an answer that does not work, or which will make our denominator 0, it's called extraneous. So be on the lookout for those sneaky ninjas. After that, we're going to multiply every single term in the numerator by our LCM. Okay, so all the numerators of our fractions will get multiplied by our LCM, and that's going to help to eliminate our fractions. All the fractions should disappear. So that's the fun part. All right, and then we're going to solve for x and check for those extraneous answers. So I know you guys are super thrilled to do examples 1, 2, and 3. So go ahead and pause the video and watch example problems 1, 2, and 3. Alrighty, now we're going to be tackling rational inequalities, which it's actually kind of similar to equations, except now we have inequalities in the mix. Okay, so our first steps, we're going to find the LCM like we did before. We're going to find where the LCM is undefined like we did before, which these values are going to be our critical numbers. And critical numbers, since we're dealing with inequalities, we're going to be dealing with a number line. So critical numbers are going to be placed on the number line. So when we find the LCM, all the places that are undefined are going to go on our number line. And since they are undefined, it has to be an open bubble because our equation can never equal it if that's where it's undefined. Okay, after that, we are going to make our inequality turn into an equation, and we're going to solve the inequality just like we would an equation. Okay, which this is going to give us one of the other answers that goes on our number line, okay, which is another one of our critical values. Okay, and then after that, we're going to be doing interval tests to see which region of the number line in between our critical values makes sense. And we're going to be substituting these values into the original to make sure we get, like for example, in example 4, we want to make sure that our values work for things that will make the equation less than or equal to 4. And with this one, we want to make sure that when we substitute in our values, that this inequality is still true. Now, since we are dealing with inequalities and number lines, we need to think back, way back to when we did absolute value equations and inequalities. Okay, we need to think back to what kind of answers we get when we have inequalities. So, what do our answers look like on a number line? You guys are so smart. You do have two options. You have an and inequality, which remember, and inequalities are when our inequalities intersect, they collide. One head's left, one head's right, and they intersect at one point. And the and inequality, our solution is everything in between the two numbers. Okay, so you can get that with an equal to symbol or a not equal to symbol. And you could also have an or as your answer, which that's when your arrows point opposite directions and they never collide. Okay, so one of your answers or your answers for these intervals on our number line are either going to be an and or an or. So you need to be on the lookout for our and our or inequalities. Okay, so go ahead and pause the video and find out how to solve rational inequalities in example 4 and 5. And the last part is just the funsy, so you will have to wait on that. And I'm pretty sure that's it. Yep. So the last part is the funsy. Oh, sorry, guys. Come on, thing. Let's go. Yes, the last thing is the funsy, so you'll have to wait on that. And guess what, you guys? That's all, folks.